Let us do a discussion on probability, and then we work out one equation. So probability. Probability is, as per the definition, is a measure of the likelihood of an event taking place. An event taking place. So once we know the definition, we are also supposed to know the range of probability. So probability of event X taking place can only be less than or equals to 1, can only be greater than or equals to 0, but cannot exceed 1, cannot exceed, cannot go below 0. So when you work out probability, your answer should lie between 0 and 1. And this probability can be stated as a fraction. It can be stated as a decimal. It can be stated as a percentage. All this depends on the equation. So if the equation is like giving us probabilities in terms of fractions, it is only good if you give them probability as fractions, or as decimals. Also give your answer in terms of decimals, but you can give in any unless you are instructed. After knowing the range of probability, how do you find probability X? Probability X is equals to the outcome favoring the event. Let me go to this side. Probability X of event X taking place is equals to the number of outcome that is favoring the event. Favors event over total outcome. Total outcome is it is the one we call probability space. With the total outcome, that is the probability of event X taking place is equal to the number of outcome favoring occurrence of event X over the number of outcome, total outcome that is expected in that situation. Then after knowing how to work out probability, we are supposed to know how to determine probability space. How do you determine probability space? Probability space is determined one by the use of tree diagram, or in some questions where we have the set of events, a set of active set of numbers, something suggesting like a set of numbers or set of events, we use a table, and we are going to see this one. Okay. So we want to before we go to a question, so we're supposed to know how to determine probability space either by tree diagram or by a table. And some will require real life situations that kind of will be asking for being very realistic, and it will give us an idea. In real life, we have to talk of probability that takes place when we have displacement, and the probability that takes place without displacement is very clear. When we talk of with replacement, if you have 5 marbles which are red, and we have others which are 4 and they are green in color, and then we want now to select. So probability space will be the total of this one, which is equals to 5 plus 4, 9. And then a number of events favoring the red will be, so probability of getting red is 5 over 9. And probability that you are going to get green is 4 over 9. Which number is favoring green? 4. Which number is favoring red? 5. So we are working in the idea that the probability is equals to the of event X taking place is equals to the number of events, the occurrence that is favoring event X over the total outcome. Now with that in mind, so we know how to draw a tree diagram, how to make a table if we have set of numbers, set of events. Then in real life situation, maybe we are choosing prefects in a class, we are electing leaders. A leader cannot be elected as a president and at the same time as a member of parliament. So we are decreasing the number. So without the displacement comes in very, very automatic. Just a minute. Somebody is asking for the class link. All right. Now let's go to a question, a typical question to address the same. And I want us to address a 10-mark question, start to see how it will behave. Probability. Trial 1, paper 2, question 18. Trial 1, paper 2, question 18. Trial 1, paper 2, question 18. Ivan, read for us the question. Ivan?
Yes.
Read the question, question 18.
An examination involves. Yes.
Continue.
An examination involves a written test and practical test. The probability that a candidate passes the written test is 6 over 11. If the candidate passes passing the practical test is 3 over 5. Otherwise, it will be 2 over 7. Illustrate this information on a tree diagram. Determine the probability that a candidate is awarded credit for passing both tests, pass for passing the written test, retake for passing one test, fail for not passing the written test.
Great. Probability will be very new. Every time it's all about reading and making proper understanding and getting the sense which is being communicated in the question. So illustrate this information on a tree diagram. We tend to see where is the chance taken, where is selection, where is probability taking place, where is the event. An examination involves written test and a practical test. The probability that a candidate passes the written test is 6/11. So the first thing in our tree diagram, it is that the probability where we have probability, this is 6/11. Probability that the candidate passes written exam. So we write written exam and then not passing. So the outcome is 2. There are chances that this candidate is going to pass an exam, which is probability of 6/11, or is going to fail an exam, and probability of failing, because the range of probability is 0 to 1, it is 1 minus 6/11, so 5/11. So probability that this candidate will fail an exam written test is 6/11, 5/11. If, now here's a condition, if the candidate passes the written test, the probability of passing practical is 3/. So we have a condition: after passing, then there is practical, not passing practical. If the candidate passes the written exam, then probability that passing practical is 3/5. So 3/5 is for passing practical. Then 2/5 not passing. Otherwise, it could be 2/7. Otherwise means now after failing written test, there are also chances that this person can pass practical test or can fail. So otherwise, meaning if the candidate fails written exam, probability that will pass exam is 2/7, practical is 2/7, failing practical is 5/7. So a probability tree diagram must have something we call kind of origin. State the origin, although it's not very necessary, but it's good to look organized, have the origin there. So we have answered part A. Illustrate this information on a tree diagram. Check on where probability is taken and where are we taking chances. So what is the outcome? The possible outcome from this probability, where we say tree diagram will help us to see the possible outcome. Where is the possible outcome? So the possible outcome is that passing written exam and passing practical, passing written exam and failing practical, failing written, passing practical, and failing written, failing practical. And failing practical. So this is the outcome. Now from the tree diagram, determine the probability that a candidate is awarded credit for passing both exams, both tests. On the tree diagram, anybody who has a concern? Anybody having a concern in the tree diagram? Maybe the formation of this tree diagram. So we are okay? Good. Silence means we are okay. Credit for passing both exams. So which outcome is favoring passing the the two exams. It is passing practical written test and passing practical test. So it is probability of this one. And then we multiply the branches. So 6 over 11 times 5 over 3 over 5, which gives us 18 over 55. That should be the probability that the candidate is awarded credit for passing both tests. That's Roman 1. Roman 2. A pass for passing the written exam. A pass for passing written exam. So written exam, it means we pass written exam and we fail practical. So it is probability that this person is going to pass written exam but will fail practical, which is equals to, we multiply the probabilities along that branch, 6 over 11 times 2 over 5, which is equals to 12 over 55. Roman 3, retake for passing one test. A retake for passing one test. So a retake for passing one test, it means it is the probability of passing written exam, failing a practical, or probability of failing written exam but is passing practical. Failing one test. So tests are 2. So we pass the written exam but fail practical, or we fail practical and pass we fail written and pass practical. So this one we multiply the probabilities. So it is 6 over 11 times 2 over 5. We say the or means it is independent event, or it is mutual exclusive event. We add, it is only one event that can take place at any given time. And the probability that we fail 5 over 11 times 2 over 7. This one gives us 12 over 55 plus 10 over 77. Work out with your calculator. What do you get? Okay. 134 over
385.
385. Good. Next, a fail for not passing the written test. A fail for not passing the written test. No. We need to interpret this one. A fail for not passing a written test. It means that this person will not. A fail for not passing. What is the condition here? Not passing written test. So whether you pass practical and you have failed written exam, it means you have failed. Whether you fail written exam and then you fail practical, it means you have failed. So the tests are 2, yes, But what guarantee you a fail is for not passing a written exam. So whatever will happen from there, it is not taken into consideration. So probability that a candidate is awarded a fail for not passing written exam. So it is probability that is going to fail written and pass practical, or probability that is going to fail written and fail practical. I expect the two conditions because we are given the aspect of failing written exam. This one, a fail for not passing the written test. So this one we multiply the probabilities along the range. It is 5 over 11 times 2 over 7 plus 5 over 11 times 5 over 7. And this one gives us 15 over 55 plus 25 over 77. And it will give you something. Right, that is the expectation we have in probability. Any question? Let us take one. Jana tulikuwa tunaulizana kama kuna kuandika. Joy. Your hand is up.
Cha, why have we put like 3 over 7 instead of 2 over 7?
Oh, it is 2 over 7. Well, it is my writing. It should be 2 over 7. Good observation. So this one will be 10 over 55 plus 25 over 77. Good. Another observation? No. Now let's go to another example. Then I leave you to attempt others. We go to trial paper 10, question 21. Trial paper 10, question 21, paper 2. Question 21. Still it is talking about Joy, read for us question 21.
The probability that three candidates, Anthony, Beatrice, and Caleb, will pass an examination are 3 over 4, 2 over 3, and 4 over 5 respectively. Find the probability that all the 3 candidates will pass, all the 3 candidates will not pass, only one of them will pass, only 2 of them will pass, at most 2 of them will pass.
Yes, still a condition on examination. The probability that 3 candidates, Anthony, Beatrice, and Caleb, will pass an examination is 3 over 4, 2 over 3, and 4 over 5, respectively. Find the probability that all the 3 candidates will pass. When we have 2 or more probabilities taking chances, we must devise a way of coming up with the probability space. The probability, the total outcome, the possible outcome. In this case, we are going to use a tree diagram. But when we have set of numbers, we want to check and see whether we can get a question that's talking about set of numbers, tossing a dice, and 2 coins. tetrahedron as such. But here we have categorically 3 people. So we are having 3 people sitting for an examination. So let's start with a tree diagram. Maybe we take the first one, the first person to be Anton. Anton will pass an exam. Anton will fail. Passing, failing. But if Anthony fails or Anthony passes, does not interfere with Beatrice passing or failing. So these are independent events. So they don't interfere. So we can have the second person taking an exam, who is Beatrice, will pass an exam, will fail, passing exam, and Beatrice failing. That is after we have taken Anthony first. After Anthony has done an exam, we observe whether he has passed or he has failed. Then we bring in consideration of Beatrice, who will also pass or fail. But passing of Anton and failing of Anton does not determine the outcome of Beatrice. So the same case, we go to the third person, who is after Beatrice has taken exam, and we have observed whether she has failed or passed. We go to Caleb. Caleb can also pass an exam or fail. Pass exam or fail. Pass, fail, pass, and fail. So these are these are independent events. They are not interfered with the outcome of the previous candidate. So what is the possible outcome? Then to make the probability tree diagram, we insert now the probabilities. Anthony passing will pass an examination is 3/4. Failing will be 1/4. Whatever that remains from 1. Caleb passing an exam is 2/3. Oh, no, not Caleb. Beatrice, 2/3, 1/3. 2/3, 1/3. Caleb passing or failing. Passing an exam is 4/5. So 1/5. 4/5 passing. 1/5. 4/5. 1/5. 4/5. Then 1/5. So this is our tree diagram. What is the possible outcome? It means all of them will pass A, B, C. Anthony passing, Beatrice passing, Caleb failing. Anthony passing, Beatrice failing, Caleb passing. Anthony passing, Beatrice failing, Caleb failing. Anthony fail, Beatrice pass, and Caleb pass exam. Anthony failing, Beatrice passing, Caleb failing. Anthony failing, Beatrice failing, Caleb passing. Anthony failing, Beatrice failing, Caleb failing. This is the probability space. Very good. This is the possible outcome. Now, at least we have analyzed the equation. Now we can go directly to answering the questions. All the 3 candidates will pass. So it is probability of Anthony passing, Beatrice passing, and Caleb passing, which will be equals to 3/4 times 2/3 times 4/5. We get the answer. That's Roman 1. Then Roman 1, what is the answer?
2/5.
2/5. Good. But B, all the three candidates will not pass. So it is probability of Anthony failing, Beatrice failing, Caleb failing, which is equals to, we multiply the respective probabilities, 1/4 times 1/3 times 1/5. And this one gives us 1/20 times 5. Is it 1/100?
Over 60.
1/60. Yes, this is 3. 1/60. And then next Roman, only one of them will pass. Only one of them will pass. So this one is a probability that only one of them will pass. We take the probability of this one. Let us highlight where they are. Probability of this, Anthony passing, Beatrice passing, Caleb failing. Only one of them will pass. Only one of them will pass. No, this one is not qualifying. Only one of them will pass. It means two will fail. This is the first one. Anthony pass, Beatrice fail, and Caleb fail. This one, Anthony fail, Beatrice pass, and Caleb fail. Another one is Anthony failing, Beatrice failing, and Caleb passing. So probability of Anthony will pass, Beatrice fail, and Caleb fail, or probability that Anthony will fail, Beatrice will pass, Caleb will fail, or probability that Anthony will fail, Beatrice will fail, and Caleb will pass. This one gives us 3/4 times 1/3 times 1/5. All means plus 1/4 times 2/3 times 1/5 plus 1/4 times 1/3 times 5 over what was the last one? It's not 5. Probability of Caleb passing is ilikuwa 4/5.
4/5.
Then we work out, this is 1/20 plus 1/30 plus 1/15. And then you get the answer. Next is probability that only two of them will pass. Only two of them will pass. So it means what? Only two of them will pass. It means probability that only two of them will pass. Let's check from our outcome. Probability that this one, probability that Anthony will pass, Beatrice will pass, Caleb will fail. This one, Anthony passing, Beatrice failing, Caleb passing. This one, Anthony failing, Beatrice passing, and Anthony failing, Beatrice, they should be 3. Only probability that only 2 of them will pass. Let's start with the first one. Anthony pass, Beatrice pass, Caleb fail. Anthony pass, Beatrice fail. Where is the other one? DOE. Probability of Anthony failing, Beatrice passing, and Caleb passing. So we have the 3 outcome. So it is probability that Anthony will pass, Beatrice will pass, and Caleb will fail. Or probability that Anthony will fail, Anthony will pass, Beatrice will fail, Caleb will pass. Or probability that Anthony will fail, Beatrice will pass, and Caleb will pass. So these are only 2 of them will pass. This is the outcome. So this one gives us 3/4 times 2/3 times 1/5 plus 3/4 times 1/3 times 4/5 plus 1/4 times 2/3 times 4/5. And this one gives us the answer as 1/10 plus 1/20 plus 2/15. And what is the final answer? You add the 3.
It is 1/6.
It is 1/5,
not 1/20.
Yes, 1/5. Good. I did not have to cancel the 4. Okay, what is the final answer now?
13/20.
13/20.
Yes.
Good. Now the part E. At most 2 of them will pass. At most 2 of them will pass. Let's get back to our tree diagram. At most 2 of them will pass. So it is the probability that at most 2 of them will pass. It is a probability of 2. It is 1 or 2. At least 2. At least 2. At most 2 of them will pass. So it is 2 or 1. Because 1 is also less than 3. At least what? At most 2 of them will pass. So it's the probability of 2 passing or probability of 1 passing. We have worked out something of this kind. Probability, we are told all of them will pass. We have worked out that one. All the 3 candidates will not pass. Hiyo tumetafuta. It is the last the last line, the last bracket, E. All of them will not pass. Tuna multiply hiyo. Anthony failing, Beatrice failing, and Caleb failing. Next is only one of them will do what? Will pass. And only two of them will pass. So when now we are told at most two of them will pass, it means that it is 2 or 1. At most, the maximum number of people who will pass are 2. So it means 1 can pass and still 2 can pass. So what is the probability that we have worked out these probabilities? So it is either 1 or 2. I think it will tafuta 1 or 2 somewhere. Probability that 1 will pass. Hii mulipata gani? Probability that 1 will pass. What is the answer? 1 over 20 plus 1 over 30 plus 115. So you will add the probability. Ulipata 1 over?
3 over 20.
Not 1. Ulipata 3 over 20. That is 1 over 20 plus 1 over 30 plus 1 over 15.
Yes.
You provide that 1 will pass. Now ya 2. Only 2 of them will pass. Tulitafuta huko chini tukapata ni 13 over 20, si ndio? So the last equation, at most 2 will pass. It's probability that 2 will pass, or probability that 1 will pass, which is 3 over 20 plus 13 over 20. And this one gives us 16 over 20 by cancellation by 4, 4, by 4, 5. 5 over 4. So probability calls for sober reasoning and exposing yourself to many questions. Anybody to answer a question? We, na mnaandika? Ukiona tunaenda mbio sana unasema. That is our question 2. Let us look for a question that might be having a set of numbers, and then we think about it. Probability question trial paper 3, question 18. Let us check that one. Hiyo ikataa, tutafute ingine. Trial 3 paper 18, question 18. Trial 3 question 18. Oh, hiyo ndio tulifanya. It looks like what we worked out. Tuachane na hiyo. Trial 4 question 22. Question 22. Trial 4 question 22. It looks almost the same like what we have worked out. Tafute ingine. Trial 6 trial 6 question 4. Trial 6 question 4. It talks about a bag contains 5 white balls, 3 black balls, and 2 green. A ball is picked at random from the bag and not replaced in 3 draws. Find the probability that of obtaining. So this one is a good question. Let us reason about it. question 4. A bag contains 5 whites in a draw of 3. The moment you have seen that the draws are 3, it calls for a tree diagram. Then we keep on checking. So it is for tree diagram. Let us start with the black. The probability of, let's start with the black, and then not black. Let's start with the white in the order that we are given. So we have white, black, green. Probability of choosing a white, a number favoring the event of picking white is 5. So 5. Total number of balls, 10. Probability over 10. Probability of picking green is 2 over 10. We are choosing for the second time. Let's move to picking for the second time. This is first selection, and then we move to the second. Second will be white, black, green, white, black, green, and then another one, white, black, and then green. That's for the second time. For the third time, we are still now choosing white, black, green. Can you see it is very chaotic? White, black, green, white, black, green. It's a little bit chaotic. White, black, green. And still we do this one. White, black, green. White, black, green. White, black, and then green. So what is for the green? Let us go to the condition that in 3 draws, find the probability of obtaining white, black, and green in third order. It looks simple, does not require all of this. So it is probability of picking what? Black, picking, probability of obtaining white, black, and a green in that order. So this one, it limits us from, we don't need this one. Can only we have like 2 marks. We don't need all of this. Let us think from the end of being critical. So the order we are told to pick is picking white. What is the probability of picking white? White. And the probability of picking black and followed by probability of picking green in that order. We are told that we don't need it is without this replacement. We are told a bag containing 5 white, 3 black, 2 green, a ball is picked at random from the bag and not replaced. You underline this one, not replaced. So probability of picking white is 5/10. Because of and, we multiply. Probability of picking black is 3, but now they were 10. We have taken 1. So how many are remaining? 9 times. Probability of picking 2. We have taken 1 white and we have taken 1 black. So green are remaining 2, and in the whole basket bag is remaining with 8. That's what it is testing us to see whether we understand with replacement and without replacement. So at the first, we had 5 whites. After in first selection, we have 5 whites. We have 3 black and 2 green. In the second selection, we have 4 white because we have taken 1, 3 black, and 2 green. In the third selection, the bag now contains 4 white, 2 black, and 2 green. So in total, hapa ni 10, here ni 9, and this one is 8. So we keep on reducing because we are told not replaced. So this one gives us year 1, year 3, year 1, year 4. So we have 5 over, no. 10 times 3, 30 times 4, 120. Is that true? Anybody wants to answer? What? Which one?
After mtu asha times hizi zote zinakuja 1/24.
Ni sawa. 120 divided by 5 is what? See 24, But since the communication. Okay. Are we together? Joy, tuko sawa?
Yes.
Very good. Gift, leo unaongea ama unatusikiza tu? Inua mkono kama unatusikiza. Yes. If we are together, what we don't have is a microphone. Oh, leo uko nayo. I can see your microphone.
I can hear. I can.
Good. Today you can communicate.
Yes.
That's where we are. Let us see whether we can get a question that talks about a table. Kama hakuna, tutavumiliana. Trial 7, question 20. talks about border. It is a 3-diagram thing. Then we go to trial 8, question 20. Question 20, it is still the same thing as the one that we worked out. In a group of 40 people, 10 are healthy. Every person of the remaining 30 has either high blood pressure, high level of cholesterol, or both. 15 have high blood pressure and 25 high level of cholesterol. If a person is selected at random from this group, what is the probability that he or she has high blood pressure? I would like you to try that one so that when we meet next, hiyo nimewaambia mjaribu question 20. I think we don't have a question that is talking about table. Question, let's see the last one. Trial 1 paper question 18. Kama hiyo ndio tulifanya. That's what we did. So we don't have a question that talks about a table, but we look for one, and once we get it, we will discuss. That's all about probability. What's a question on probability?
Yeah.
Yes.
Yeah. Assignment. So we had one for tetrahedron.
In the assignment?
Yes.
Uko nayo hapo?
Yes.
Hebu soma vile inasema.
A tetrahedron has its faces labeled 2, 4, 6, and 8.
Ngoja kidogo. Soma.
A tetrahedron has its faces labeled 2, 4, 6, and 8.
A tetrahedron has its faces written as 4,
2, 4, 6, and 8. The size of the tetrahedron are best such that the probabilities of the size that it lands on when tossed are 2H, 4H, 6H, and 8H respectively. The first
Pole. A tetrahedron has its faces written as 4, 2, 6, and 8. 4 sides, eh?
Yes. Yes.
Well, and now continue from there.
The sides of the tetrahedron are biased such that the probabilities of the side that it lands on when tossed are 2H, 4H, 6H, and 8H respectively. The first question, find the value of H. The second question, if the tetrahedron is tossed twice, Find the probability that it lands on the side marked 8 in the two tosses.
Beth.
Yes.
Beth, I lost you along
Yes.
the way. Sorry for that. Somebody made a call. Yenye imeharibu kila kitu. Tuende kazi. Umeniambia a tetrahedron as for 3,
2, 2,
2,
4, 6, and 8.
a tetrahedron.
Yes, has its faces labeled 2, 4, 6, and 8.
6 and 8 would, eh?
Yes. The sides of tetrahedron are biased such that the probabilities of the side that it lands on when tossed are 2H, 4H, 6H, and 8H respectively. The first question, find the value of H. The second question,
find the value
if the
of H.
The second question, if the tetrahedron is tossed twice, find the probability that it lands on the side marked 8 in the two tosses.
8 and?
The probability that it lands on the side marked 8 in the two tosses.
8 in the two tosses.
Yes.
Hivyo.
It only had two.
So let us now start bringing in probability. Probability says what? What is the range of probability? What is the probability of getting it is biased in a way that there is 2H, 4H, Evo. Then we are asked to determine the value of H. If it is a tetrahedron, it means that the probability of getting a 2, a 4, a 6, and 8, because they are like standing equal chances, they will be the same. Then you have said that find the probability that the probabilities are biased. Nataka unisomee statement before listing the 2H, 4H, and 6H. What is the statement there?
The sides of tetrahedron are biased such that the probabilities of the side that it lands on when tossed are 2H, 4H, 6H, and 8H respectively.
Well, so these are the probabilities, eh? And the range of probability starts from 0 all the way to 1. So the sum of all the probabilities should give us 1. So 2H plus 4H plus 6H should give us 1 because these are the probabilities. So this one gives us 6H, 12H, 20H. So 20H is equals to 1 over 20 over 20. So H is equals to 1 over 20. Have you seen where we are getting the idea from? Range of probabilities. Yes. The sum of probabilities in the whole event must add up to 1. And we are told the probabilities of every side is biased, such that the probability of getting the first one is 2H, 4H, 6H, and 8H. So what is the probability the sum of probabilities should give us 1. So the H is 1 over 20. Now, next equation, we are told determine the probability that it is thrown twice, tossed twice. Then determine the probability that the two faces will show up will consist of 8. So probability of 8 will be 8H. 8H is 8 into 1 over 20. And this one will be by 4, 2 by 4, 5. 2 over 5. So it is probability of getting 8 and 8. So it is a probability of getting 8 and 8. These are independent events. So it will be 2 over 5 times 2 over 5, which gives us 4 over 25 as the answer for the 2. If the faces will show up and 8, all of them. Are we in agreement?
No.
Okay, now you can ask, where are we exactly far from each other?
Cha, here
Yes.
you are saying, you are when you have gotten 8H, Cha, why are you saying 8 and 8? Cha, mbona una multiply mbili?
Hebu nisomee part B. Part B nasema nini of the equation?
If the tetrahedron is tossed twice, find the probability that it lands on the side marked 8 in the two tosses.
The side marked 8 in the two tosses. So
Yes.
it is getting 8 and 8. It is not 8 or 8. The first toss lands at 8. Unaweka hiyo kando, and the second toss it lands at 8. So it is probability of getting 8 and 8. Independent events we multiply. So the probability of getting this one is 8H. And what was 8H? H was what? 1 over 20.
20.
So this is 8 over 20, simplifies to 2 over 5. Sindio? So it's probability of getting 8 and the probability of getting an 8 is equals to 2 over 5 times 2 over 5. This one gives us 4 over 25. It is you toss once, you get an 8. And you toss for the second time, you also get 8. So it is independent events. So we multiply them. It is not all. The first toss, you get 8. It is not influencing the occurrence of 8 in the next toss. So we call them independent events. Very good. Let me check for some people. Another question on the probability before we move on. Ana mtu hapa ananipea kidole ya Gen Z. Okay, Eunice, your hand is up.
Yes. Kwa exam kulikuwa na hii question ya probability ya tetrahedron. Inasoma two fair dices, a regular tetrahedron, 4 faces, and the other cube are drawn. The scores are added together. Draw a table to show all possible outcomes.
Very good. That's the question I was looking for. A question that has set of numbers. So we are told that Hebu anza kusoma sasa tuisikie. Eunice.
2 fair dices, one a regular tetrahedron, 4 faces, and another a cube are drawn. The scores are added.
There is a cube, and
There
there is
a cube and
a tetrahedron,
which has 4 faces,
and
a cube.
Now let us concentrate on that one first. There is number 1. There is a tetrahedron.
Yes.
Tetrahedron has how many sides?
4 faces.
4 faces. And a cube has how many faces? A cube has how many faces?
It is not specified.
Wewe, cube tunajua ni nini? A cube has how many faces? Gift. Yes, we have, this one is a tetrahedron. And this side we have a cube. A cube has face 1, 2, 3, 4, 5, 6 faces. A tetrahedron has 4. 1, 2, 3, 4. So when you toss the 2, a tetrahedron will land maybe on 1, 2, 3, or 4. A cube will land on either 1, 2, 3, 4, 5, 6. Then there is a condition you are given that the sum of the faces, sindio? Eunice, the sum of the faces inakuwa ngapi? That's this. We toss and then we sum up the faces. So there are chances we are going to get a 1 on tetrahedron and a 1 on a cube. So we sum them. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 1 plus 2, 3. 2 plus 2, 4. 3 plus 2, 5. 4 plus 2, 6. 1 plus 3, 4. 1 plus 3, 5. 3 plus 3, 6. 4 plus 3, 7. 1 plus 4, 5. 6, 7. 4 plus 4, 8. 1 plus 5, 6. 7, 8, 9. 1 plus 6, 7, 8, 9, 10. That's the table that you are supposed to draw. We have answered the first question. Eunice?
Yes. Question B.
Yes.
Find the probability that the sum is 6.
That the sum is?
6.
The sum is 6. Probability that you are going to get a 6. So probability of getting 6 is getting these ones. Getting 6. How many 6 are there? 1, 2, 3, 4. Favoring the outcome of getting 6, 4. Probability space in the table. All of these ones. This is the sum that we have. 4 times 6, 24. 1 over 6. Next question.
Pardon, teacher.
Umetoa wapi 24?
Umetoa wapi 24? Yeah. Count the boxes. Count the sum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Umeona kwenye zimetoka? So that's the probability space. Now, what is the next question, Eunice?
The sum is an odd number.
Probability of getting odd number. The sum is odd. Odd, we have 3, which are a 2. So we have 3, which are a 2. Odd, remember we have 5. Another odd number we have 7. Another odd number we have 9. So in total, how many are they? 2 plus 4. 6. 6 plus 1, 2, 3, 4. 10. 10 plus 2, 12. So the outcome favoring the event, 12 over total 24, which gives us a half. Are we in agreement?
Yes.
Yes, Eunice, next question.
The sum is 6 or 9.
Probability of getting 6 or 9. Mutually exclusive event or 9. So it is the probability of getting a 6 plus probability of getting a 9. Probability of getting a 6 is this one, the 1 over 6. Si tulipata hiyo. Probability of getting 9 is 2 over 24. So it is 1 over 6 plus 1 over 12. What is the answer?
1 over 4.
1 over 4. Kuna swali lingine? Ama imeisha?
Hakuna C. If a
But
player
C
wins
says
a
what?
game, if a player wins a game by drawing a sum of 6 or 9, draw a T diagram to find the probability that he wins at least once when the dice are drawn twice.
Now condition ingine imekuja hapo. If a player wins a game by getting what?
6 or 9.
6 or 9. So
Yeah.
wins a game by getting a 6 or 9. Sindio?
Yes.
Throw a probability tree diagram to do what?
Find the probability that he wins at least one when the dice are drawn twice.
Wins at least one when the dice are drawn twice. So probability that you will win is either you get a 6, a sum of 6 or a sum of 9. Sindio? So there is winning and there is losing that game. Sindio? This is the first, for the first throw, winning is 1 over 4 and losing is 3 over 4. Then we go to the second throw. After throwing for the second time, we also win or lose. We also win or lose. Or lose. Find the probability that we'll win at least what?
At least once when the dice are drawn twice.
Dice thrown twice, but will win at least one. So it is a probability that this person is going to win twice, or probability of winning at least one. So na hii iko, and this one is there. So what is missing is only when he is losing both. So it is probability of win or probability of win, fail, or probability that you will lose and win. In other words, if you add all of these, you are going to get a probability of 1. Ukiongeza zote hapa. So it is, we get it, you will either multiply this one, which will be equals to their quarter times 1/4 plus, both of them will win, plus this is still 3/4, win 1/4 and lose 3/4, or probability that will lose and then win. That will give you the answer. You get this one, you add this, you add this. There is also an alternative. When you are told at least 1, it means it is 1 or more. So if you add this one, you get the answer. It is 1 or more. So it is probability of at least 1 is equals to 1 minus probability that you will lose and will lose, which is 1 minus 3/4 times 3/4, which is equals to 1 minus 9/16, which gives us 9/16 is 7/16 as the answer. So that's what was expected of you. So when we have a set of numbers, this is a set of numbers 1 to 4. This is also a set of numbers 1 to 6. We need a table for us to find the probability space. Sawa sawa.
Cha,
Mm-hmm.
cha niko na swali.
Yes.
So ukiambi umesema cha umesema sasa ukiulizwa ya at least 1 cha ndio utafanya 1 minus your probability yenye umepata.
That's okay. It comes in this way. When you are told at least 1, it means 1 or more, including all of them. At least 1 means 1 or more. So it is only the one, the probability we exclude ni hiyo tu ya mwisho. So now tuko na 3 probabilities probability that will win and win, or probability that will win and lose, or probability that will win, lose, win, or probability that will lose and lose. So lose zote. So when we are told at least 1, it means this one qualify. At least 1, it is 2 or 1 or more. This one also qualify because there is a 1 win here. This one also will qualify because there is 1. So the only thing which is remaining that does not qualify is this one. And we know that when we add all of these probabilities, should give us 1. So now it is 1 minus what will not qualify. And what will not qualify is probability that will lose and will lose. So when you are told at least 1, it means 1 or more. Another question on the probability. Probability is so wide, and but it only calls for critical reading, and then have a few aspects that you need a table to know the probability space. You need a tree diagram if we have multiple choices. But when we have set of numbers like the tetrahedron, a die, or sum, we use we are given a condition. So we use that condition and we come up with a table. All right. Another question on the probability. Let us now do the obvious before we decide what we are going to do next. There are some questions that are on matrices. I think you were given one question. On matrices, what are the expectations? Matrices is very simple, but one aspect we are supposed to know, it is matrices actually starts from multiplication. So we are supposed to know how to multiply. From multiplication, that's where we do the inverse of a matrix, and the inverse calls for you to know how to find the determinant of a matrix. Number 3, after getting the inverse and determinant, now we define what a singular matrix is. A singular matrix, a matrix that has no inverse. When do we know that it does not have an inverse? It is when the determinant is equals to 0. So singular matrix is a matrix that has no inverse, a matrix that has a determinant of 0, and in a transformation, it's a matrix that maps a triangle onto a straight line. So if you hear a description that there is a matrix that maps an object onto a straight line, definitely that is a singular matrix. So singular matrix has no inverse, singular matrix has a determinant of 0, it maps an object onto a straight line. Number 4, with the inverse, we are supposed to solve simultaneous equation. Simultaneous equations using matrix method. Let's go and work out one example on matrices. Matrices, we have trial 2, paper 1, question 15. Let us see how it behaves. Trial 2, paper 1, question 16. Trial 2, paper 1, question 15. Very good. Abigail, soma hiyo. Abigail, are you in? Abigail, yeah, you go. Eunice, you did not lower your hand. Stacy, tusome. Read for us question 15.
Find the matrix 7, 3, 4, 2. Method solve the solution. X plus.
You can see it's a straightforward question. Find the inverse of this one using matrix method, solve the simultaneous equations. So inverse. The first thing to get when you are getting inverse, you need determinant. Tukasema determinant is equals to what? Determinant is equals to what, Dabi? Determinant is equals to? Okay, from this matrix, determinant is equals to? Debbie is not talking, or she has challenges with the
7 times 2 minus 4 times 3.
7 times 2 minus 4 times 3. I think she's correct. 14 minus 12,
2.
Which gives us 2.
2.
So that's our determinant. Then now we want the inverse. What is the inverse of this one? Inverse, I want to hear from Gloria. Gloria Wanjiro. What is the inverse? Get us the process of getting the inverse. Process of getting the inverse, Susan.
These two, we are going to put it as a fraction equal 1/2.
Yes.
And then 2 and 7 will interchange. Kwenye 7 iko tuweke 2, alafu kwenye 2 iko tuweke 7. And then 3 and 4 change signs, kwa negative.
Oh, good. That's the inverse. But we don't stop at this level. If the question is saying find the inverse, you must evaluate and give your answer as 1, -2, -1.5, and 3.5. This is what will give you a mark. Zingine zote is a process. And you can see it is 1 mark. So if you are told find the inverse of the matrix, you must go ahead and evaluate. Don't stop at the level of getting 1 over determinant into brackets, interchange the elements of the main diagonal, change the signs of the element of the leading diagonal. We must go until we evaluate. And then now we are told to, using matrix method, solve the simultaneous equations. Using matrix method, solve the simultaneous equations. We said that you arrange the you write the equation in matrix form. So our equation will be 7, 4, 3, 2, x, y equals to 14, 8. I've done it in a very strategic way that I'm avoiding so many writings. Once I skip some space here and I skip another space here, so that I will now insert this is matrix, the matrix form. So what I will do, I will insert the universe. The universe is 1 over 2 into 2, negative 4, negative 3. And here 1 over 2 into 2, negative 3, negative 4, and 7. So that you save on time. You don't write everything. As you write the equation in a matrix form, also write it in a way that it is you skip some space, you give some space so that you are going to insert the universe directly. So if you multiply this one, we don't struggle so much. If you are very sure of your universe, it will give you 1, 0, 0, 1. Don't even think of multiplying, because it is known that if you multiply a matrix and this universe, you multiply a matrix and this universe, it gives us an identity matrix. Identity matrix is 1, 0, 0, 1. xy is equals to 1 over 2. Now this other one you must multiply. 2 times 14, 28. 28 plus 32, 60. Negative 3 times, oh, not 60. It was a negative, eh? Serious? 4 is negative. So 28 minus 32, negative 4. Negative 3 times this one, negative 42. Negative 42, no. This time is the one. Negative 42 plus 56. 14, eh? Is it 14? Then xy, open a bracket, negative 2, and then 7. So the value of x is equals to negative 2. The value of y is equals to 7. Thus, we use the matrix method to solve simultaneous equations. Wonderful. Now, I want to give you one that you'll try. One that you'll try, and as I wait for the answer,